All right, for this lesson, we're going to do a bit of a refresher on how to count atoms, and specifically we're talking about counting atoms in chemical formulas. You should have already downloaded a copy of the handout that goes with this so that you can follow along and fill it out as you go. All right, so first of all, let's talk about the symbol. So the symbol for an element will represent one atom of that element. So for example, if you see the symbol Ba, that means that you have one barium atom. All right. The same goes for any element on the periodic table. If you have a C, it means one carbon atom. If you have an H, it means one hydrogen atom, etc., etc., etc. Now, if you have numbers around your symbol, so for example, if you have what is called a subscript, so to the bottom right of your element symbol, if you have a number there, that tells you how many of that atom you have. If there is no number there, that means you have one. So if you notice with our first example, Ba, there is no number here to the bottom right of the symbol. That means there's one. If you have a number there, that means it has that many of that element. So for example, if you have Cl2, that means that you have 2 chlorine atoms. If you had C with a 4 underneath to the bottom right, that would mean you have 4 carbon atoms, and so on. All right, so the next is a subscript outside of a bracket. Now, that means that if you have a subscript outside of a bracket, everything inside the bracket gets multiplied. So let's take a look at this example here. We have 3 elements in this compound. So this compound is called calcium phosphate, and we'll get into where the phosphate comes from later on in the unit. It has Ca with the subscript 3, which tells us that we have 3 calcium atoms. And then we have a bracket and then a closed bracket here. And in between, we have PO with a subscript 4. Well, the P does not have a subscript, so that means we only have one of those. The O has a subscript 4, so that means we have 4 oxygen atoms. But it's inside a set of brackets. And what that bracket means is that we have a number of copies of this PO4. And the number of copies we have is indicated by this subscript on the outside here, this 2. So to figure out how many PO4s we have, we look at outside and we see a 2. So that means we have 2 PO4s. That means that we have 2 of everything that is inside the brackets. So inside the brackets, we had 1 phosphorus. We have a 2 outside. So to figure out the total number of phosphorus, it's 2 times 1, which is equal to 2 phosphorus atoms. How many oxygen do we have? We have 2 outside the bracket, and we have 4 inside, so we have 2 times 4 is equal to 8 oxygen atoms. All right, so the subscript tells you not only how many of each individual element we have, but it also tells us how many of each group of elements we have. All right, so the next number is what's called a coefficient. So we had here a subscript. It was a lower to the right number. A coefficient is going to go in front of an element, all right? And some of you may be wondering, well, what's the difference? Why would we have a subscript or a coefficient? Like, why do we have 2 different things here? Well, this tells us that within this molecule, within this clump of elements that are stuck together, we have 3 calcium atoms in that clump. A number 3 in front of this tells us that we have 3 carbon atoms. So we have a coefficient in front of the carbon that says we have 3 of these. They are not attached to each other. We could have a carbon here, and a carbon here, and a carbon here. It just means that we have a total of 3 carbon atoms somewhere in the space that we are measuring, but they are not attached. All right, so in here, we have all of these elements. We've got subscripts in here. That tells us within the molecule, all of these atoms are attached. There are 3 calcium. There are 2 times 1 is 2 phosphorus, and 2 times 4 is 8 oxygen. All of these atoms are stuck together in a molecule. These 3 carbon atoms are not. They are separate from each other. All right? Now, we have here NaSO4 with a 2 coefficient in front. Now, the trick to figuring this stuff out is you should always look at how many elements are in the compound first, and then how many of those compounds do we have. All right, so in this case, we had 3 carbon. So how many elements did we have in one compound? Well, it's just a single atom. So we only had 1 carbon, but we had 3 of those. So 3 times 1 is 3 carbon atoms. In this case, we have an NaSO4. So we have a sodium, a sulfur, and an oxygen all stuck together. And all of these oxygens all stuck together. So we have 3 elements in here. We have a total of 1 sodium because there is no number afterwards. We have 1 sulfur because there's no number afterwards. And we have 4 oxygen. All right, so we have 1 sodium, 1 sulfur, 4 oxygen all stuck together. And we have 2 copies of it. All right, so that 2 coefficient in front means we have 2 of these. So how do we figure out how many of each element we have? Well, in 1 copy, we would have 1 sodium, 1 sulfur, and 4 oxygen. But we have 2 copies of it, so we have to multiply. So 2 times 1 is 2 sodium atoms. 2 times 1 is 2 sulfur atoms. And 2 times 4 is 8 oxygen atoms. All right, so you can see this, we had to multiply the 2 times the 4. It's similar to what we did up here. We had a 2 outside of the brackets, so we multiplied 2 times 4. All right, the same kind of result. So, a couple of examples here. I have 2 H2O molecules. Well, how many molecules of H2O do I have? The 2 coefficient tells me I have 2 molecules of H2O. How many atoms of hydrogen do I have? Well, there's a coefficient of 2 after the H, so that means I have 2 hydrogen in a molecule, and I have 2 molecules, so 2 times 2 is 4 hydrogen, and I've got no subscript after the O, so that means I only have 1 oxygen. 2 times 1 is 2 oxygen. How about for this? We have here what's called sodium sulfate. In 1 molecule, I have 2 sodium, I have 1 sulfur, and I have 4 oxygen. But I have, because there's a coefficient of 3, I have 3 of these. I've got 3 molecules of sodium sulfate. I have 3 times 2 is 6 sodium atoms. I have 3 times 1, which is 3 sulfur. And I have 3 times 4, which is 12 oxygen. So our last example, I have 4 PbNO3 2. So that means I have 4 molecules of, and this is lead nitrate, all right? Now, this is probably the most complicated atom or molecule you're going to run into. In this example, we have 4 of these, so that means I've got 4 molecules of lead nitrate. I only have 1 lead atom in each molecule, but there are 4 molecules, so I have 4 times 1, that's 4 lead. I have, in 1 molecule, I have 1 nitrogen times 2, because there are 2 of these clumps. So 2 times 1 is 2, but there are 4 molecules. So 1 times 2 times 4 are 8 nitrogen. And then I have 3 oxygen inside the brackets. Outside the brackets, I have a 2, so that means I have 2 times 3, that's 6. And then I have to multiply by the 4, so that means I've got 24 oxygen total. All right? So you're going to practice a little bit with that, and then you can check the answers to make sure you're doing it correctly.